Okay, first of all, with this problem, I'm going to put a problem on tomorrow's quiz that looks like this. It's not going to look exactly like this, like identical to this. It might not have a 1 here, but the bones of this problem are going to show up on tomorrow's quiz. Okay? Okay, everybody? So if you're watching this video, now you know one of the problems, what one of the problems is going to look like tomorrow. All right, so let's talk about what we would do with this problem. How we could simplify this. Oops. I always forget that. Always forget. Toolbox. Write everything in sine or cosine form. Yeah, I could do that. Okay? I could. Should I? Is the other question. So, if I did that, don't write this down, but if I wrote everything in sine or cosine form, then this cosecant I would have to replace with 1 over sine x. And then I have a fraction with a constant, like a non-fraction, in a fraction. That is just a mess that I don't want to have to deal with right now. So even though I could write that as 1 over sine, and even though I could write this as 1 over cosine, it's not the best approach because of this 1 that's up here. Okay? So, yes I could, but no I won't. Alright? So, we're not going to do this. What about manipulating and substituting Pythagorean identities for squared terms? There are no squared terms here. So, I'm not going to do that. What about factoring? Factoring in general, we look for plus and minus signs, and then we look on either side of that to see if they have anything in common. All that I have here is a cotangent, and I don't have a cotangent here. And plus, we don't factor from fractions out of the problem. We just don't do that. Okay? That's beyond our possibility. So, we're not factoring. Not going to factor. This says, find a common denominator and combine fractions. Now, let's talk about this one. I have one fraction here. I suppose I could do this and call that a fraction. And then I could find a common denominator for these fractions. By multiplying, right, like we did in the opener, like we did here, where we took this and multiplied it here, and we took this and multiplied it here and here. I suppose I could do that. Oops. So, is it possible? Yeah, maybe. Let's put a check there. We could do that, but let's keep going. What about factoring by grouping? No. What about multiplying a binomial in a fraction by its conjugate to produce the difference of squares? Okay, I've been saying for almost a week now how rare it is that we use this tool, but this is a scenario where I could do that. This is a binomial in a fraction. Its conjugate, like we saw in the opener, like Nicholas was kind enough to share with us his supreme knowledge, I could, and don't write this down, because I'm not saying I want to do this, I'm just saying I could multiply by the conjugate of that on the top and the bottom. Now, that would create quite a bit of work for us. All right? It's not a terrible idea, but it's not the best approach to a problem like this. Not this one. Okay? Because what I would do with that is then I'd produce the difference of squares, then I'd have a squared term, I'd have a cosecant squared in there, and then I could maybe start looking at Pythagorean identities. But last but not least, so this is a, yeah, maybe. Last but not least, we haven't done this yet. So I want to play with this toy, right? This tool. Decompose a fraction that has a binomial on the top but not on the bottom. We have that here. We have a binomial on the top, but not on the bottom. So this problem, I want to try decomposing the fraction. And might I remind you, there is a problem like this on tomorrow's quiz. So, confronted with a situation similar to this in the future, you can always decompose the fraction. What does that look like? That means we're taking the number 1 and we're writing it over secant x. And then we're taking the plus sign, and then we're taking cosecant x, and also writing that over secant x. Now we have this. This is our problem now. That's the decomposition of the fraction right there. Okay? Now we're here. We've used the tool. What are we supposed to do? Then we're supposed to simplify what we see. Right? So how do we do that? Well, secant, cosecant, cotangent. A lot of different terms going on up here. If we went back to this, okay, we said we didn't want to do this right away, writing everything in terms of sine and cosine. The reason we didn't want to do that was because we had this in the numerator of a fraction, but guess what? Now they're all in separate fractions. So now it might make sense to write everything in its sine or cosine form. Like, what is 1 over secant? Well, we know that secant is 1 over cosine. And if we do the switcheroo here, which we can, cosine is 1 over secant. We've talked about the switcheroo before. Take that out of the denominator, put that in. We've done the switcheroo. So 1 over secant is equal to cosine. That's convenient. Now here, this cosecant, let's do this color coding. Color coding. Color coding is important sometimes. If you're colorblind, I'm sorry. This might not help you, but what's cosecant? Cosecant is 1 over sine x, and secant x is 1 over cosine x. Cotangent, in terms of sine and cosine, as we're trying to do here, right? Cosine, sine, cosine. Cotangent is cosine x over sine x. So there's the tool used, writing everything in terms of sine and cosine. Now I can simplify. We've got this mess in the middle. We've got 2 fractions. One on the top, one on the bottom. How do we clean up something that has 2 fractions like this? We take the bottom one, we flip it over, and we multiply. So we're going to take this, we're going to flip it upside down, and we're going to multiply it times the top. Now, rather than writing out even more, see if you can watch this. Okay? The pinky, that's cosine x. Where's the pinky going to go? On the top. The index finger, that's 1. Where's that going to go? On the bottom. So what's going to happen to this fraction of fractions of fractions? It's going to become cosine x over sine x. I've got over here cosine x over sine x, and then don't forget the cosine x here in the front. That's the simplifying. I didn't use a tool for that, I just simplified what was there. I saw a fraction sandwich and I said, alright, I got to clean that up. How many fraction sandwiches have we had to clean up to this point? Half a dozen? Okay. Should be comfortable seeing that. If you've seen all of these problems, you've seen that quite a bit. Now when you look at this, can we clean this up? Certainly can. Cosine over sine, cosine over sine, right? These are opposites, they cancel each other out. Booyah. There you go. So, to review, decomposed the fraction, couldn't simplify it anymore, went back to the toolbox, wrote everything in terms of sine and cosine, simplified that, done. Mic drop. On the quiz tomorrow.